In this video, I want to talk about the equations of accelerated motion. Okay, you know that there should be an acceleration for this kind of movement. Okay, recall the definition of acceleration related to moving particle. If you remember, we have this definition. Change in velocity per unit time, or v2 minus v1 over t. Okay, now, please look at this figure here. Imagine I have a moving particle, and this is the start point. Of course, x is 0, displacement is 0 here at the beginning, t is 0. I mean, time value should be 0 at the beginning, and it's going to the right along a straight line. Okay, for example, here, imagine your particle is here. So the time of this traveling, imagine it is t, which is arbitrary. It can be anything. For example, 1 second, 5 seconds, 25 seconds, 43 seconds, whatever. It can be anything. Therefore, that's arbitrary value. It is general form. Therefore, this is general position, and you have general time for this position. And of course, from here to here, you have displacement, which is x. At the beginning, look at this one. At the beginning, imagine you have a velocity for your moving particle. I want to call it V0. What is V0? It is called initial velocity, or velocity of the particle at t equal to 0. Sometimes it is 0, sometimes it is not 0. It depends on the situation. But in general, it is V0. If you have V0 for your moving particle and you have acceleration for this position, which is arbitrary position, you have t, the time of this position, and you have x here, which is displacement for your position, and you have velocity for your moving particle at this moment. Therefore, you have two velocities. The first one is v0, that's initial velocity, and you have velocity at t, or arbitrary position. It is v. Consequently, here, you can apply this equation for this moving particle according to this figure. A equal to, instead of V2 here, you can use V here according to this figure. So, because this is second velocity according to this situation, this is second velocity, therefore use the V instead of V2. Minus, instead of V1, you have this velocity, that's V0. Therefore, first velocity, according to this condition, it is V0. Therefore, instead of V1, I want to use V0. And time, it's t, because from here to here, it takes time, which is t. Time of traveling to reach this position. Obviously, it is t. Okay. Therefore, instead of first equation or first form, I want to change this form, which is a equal to v minus v0 over t. So you have the same equation, but it has different form, or it has different appearance. Okay, now let's multiply. I want to multiply a and t. If you multiply it, it is v minus v0 equal to at. Therefore, from here, v equal to v0 plus at. This is the equation of velocity for accelerated motion. Very important. Pay attention, please. This equation is resulted from initial definition of acceleration. Therefore, I just proved this equation that it is called velocity equation. So you can use this equation to find the velocity of your particle. What is V0? V0 is initial velocity. Or velocity at t equal to 0. Sometimes it can be 0, sometimes it is not 0. It depends on the condition of your movement. The unit is in meter per second. T is time. Unit is in seconds. A is acceleration of your particle. Unit is in meter per second square. You know, it has this unit. And the velocity of this position here, it has unit of meter per second. This is the first equation in accelerated motion. Example. There's a particle, there's a moving particle, it's going to the right. Okay, acceleration of this particle is 3 meter per second square. If initial velocity of this particle at the beginning, I mean velocity of this body at t equal to 0, or v0 is 5 meter per second, after 4 seconds, what is the velocity of this particle? If it has acceleration of 3. Okay. Sorry. Follow this equation. V equal to V0 plus 80. Okay, V equal to V0, you know, it is 5. A, it is 3. And T, it is 4. That's 5 plus 3 times 4, that's 12. Therefore, V is 17 meter per second. Answer of the problem. Next example. Imagine there is a particle and it has a velocity of 22 meter per second. V is 22 meter per second. Let me draw the figure. That's better. I prefer the figure here. Going to the right. Velocity at this moment, or at the beginning, it is 22. This one is better. Okay, if acceleration of this particle is minus 4 meter per second square, minus 4. That's negative. It means you should have decreasing velocity. What is the required time to stop this particle? I mean, final velocity should be 0. Therefore, how long does it take that the particle will stop? Find this time value in order to satisfy this condition according to this acceleration. Okay, you know we have a formula. V equal to AT plus V0. Okay, according to this figure and according to the condition, what do you think regarding initial velocity? What is the initial velocity of this particle? Obviously, it is 22 because this is the velocity at the beginning. So V0 is 22. And what is final velocity? Of course, it is 0. Therefore, V0 is 22, this one. And final V, that's 0. Plug in here. V is 0 equal to minus 4 times t plus 22. Therefore, you can find t value for t equal to 22. Therefore, you can find t. T is 22 divided by 4. That's 5.5 seconds. It means it takes 5.5 seconds that the particle will stop right there on the right side here. This one. Thank you.